For this problem, I'll start off by treating it as a homogeneous differential equation. We'll have y triple prime minus 6 times y double prime is equal to 0. So the auxiliary equation will be m cubed minus 6 times m squared is equal to 0. We can factor m squared out. It'll be m squared times m minus 6 is equal to 0. The first two roots, m1 and m2, are both going to be equal to 0. And the third root, m3, is going to be equal to 6. So we know the complementary solution, yc, is going to be the form c1 times e to the m1x plus c2 times x times e to the m2x plus c3 times e to the m3x. So yc is going to be equal to c1 times e to the 0x plus c2 times x times e to the 0x plus c3 times e to the 6x. E to the 0x is 1, so both of those e to the 0x terms will cancel. We'll have yc is equal to c1 plus c2 times x plus c3 times e to the 6x. Now that we found yc, we have to find yp. G of x was given as 3 minus cosine x. This first term is a constant, so in my yp I'll include a to represent the constant. And if you remember, whenever we have a cosine or a sine term, we have to account for the possibility of having both a cosine and a sine. So yp will be a plus b times cosine x plus c times sine x. Now if you notice, one of the terms in yp is just a constant, and one of the terms in yc is also just a constant. This is not allowed, so to fix this, all we have to do is multiply a with an additional x. However, we have x times some constant, also as one of our terms in yc. To fix this, all we have to do is multiply with another x. So we'll have x squared times a. So yp is going to be a x squared plus b times cosine x plus c times sine x. We can now take the derivative of yp, so yp prime is going to be equal to 2 times ax minus b times sine x plus c times cosine x. We can take the derivative again. Yp double prime is going to be 2a minus b times cosine x minus c times sine x. And we can take the derivative once more to find yp triple prime. It'll be b sine x minus c cosine x. The original differential equation was y triple prime minus 6 times y double prime is equal to 3 minus cosine x. Because yp is a solution to this differential equation, we can plug in yp triple prime and yp double prime into this differential equation here. Yp triple prime was b times sine x minus c times cosine x. That'll be minus 6 times y double prime, which was 2a minus b cosine x minus c sine x. That was all equal to 3 minus cosine x. I'll distribute this 6 to all the terms in yp double prime. We'll get b sine x minus c cosine x minus 12a plus 6b times cosine x plus 6c times sine x is equal to 3 minus cosine x. We can now compare coefficients. The coefficient of a constant term on the right is 3, and on the left it's negative 12a. So we can set negative 12a equal to 3. So a will be equal to 3 over negative 12, which is negative 1/4. We can compare coefficients for cosine x. On the left, we have negative c, as well as 6b. So it'll be negative c plus 6b. And on the right, it's negative 1. So 6b will be equal to c minus 1. Lastly, we can compare coefficients for sine x. We have this positive b on the left, as well as this positive 6c on the left. And on the right, we have nothing, so it'll be 0. We'll find that b is equal to negative 6c. We can plug this b into the other equation. We'll have 6 times negative 6c is equal to c minus 1. It'll be negative 36 times c is equal to c minus 1. I can subtract both sides by c. We'll have negative 37c is equal to negative 1. So c will be equal to 1 over 37. Now all we need to do is plug this into this equation to find b. So b will be equal to negative 6 times 1 over 37. So b will be equal to negative 6 over 37. Now that we have a, b, and c, I'll rewrite yp. It was equal to ax squared plus b times cosine x plus c times sine x. We found that a was negative 1/4, so yp will be equal to negative 1/4 x squared. We found that b was negative 6 over 37, so it'll be minus 6 over 37 times cosine x. And we found that c was positive 1 over 37, so it'll be plus 1 over 37 times sine x. Earlier, we found that yc was equal to c1 plus c2 times x plus c3 times e to the 6x, and the general solution y is given as yc plus yp. So y is going to be equal to yc, which was c1, plus c2 times x, plus c3 times e to the 6x, plus yp, which was negative 1/4 times x squared, minus 6 over 37 times cosine x, plus 1 over 37 times sine x. So that is our final answer. If this video helped you, consider subscribing.